know you're practicing science every time you go fishing. But how do you know? Well, fishing has always been a way to raise questions about the natural world, the underwater natural world, that is, because that's where fish live. And raising questions about the natural world is science. Where should I go to go fishing? What bait should I use to catch the fish? How far should I cast? How fast should I retrieve it? What's the best way to rig my bait to have the best chance of catching that fish? So these are the types of questions that we seek every time we go fishing. So hello there anglers, Lisa here again with the IGFA. Today during our virtual field trip, we're doing something a bit different. We are going to show you how you can use recreational fishing to understand the practice of science and the scientific method. And so the scientific method has been used for many, many years as the main method for students to learn how to conduct an experiment. You ask a question, you do your research, come up with a hypothesis, do your experiment, analyze your results, form your conclusion, and there you go. However, science does not always follow this defined method. An investigation involves collecting information, while an experiment is a tightly controlled investigation that tests a hypothesis. So a hypothesis is an educated guess that is formed based on observations and a little bit of research. And then the experiment is designed to test whether that hypothesis is true or not. And that's the purpose of an experiment. What are we exploring or testing in our experiment today? Well, we are going to go fishing to see which rig of a live bait fish works the best. That's our problem. We identified it. Which rig works the best to catch us some fish? Well, before we do that, we have to do a little bit of research. Okay, so we have a lot of book resources, magazine resources to help us figure out this problem. Okay, so through our research, we found out that there are 3 ideal ways to rig a live bait fish: through the nose, through the back, and through the peduncle. The peduncle is the base of the tail. So which of these 3 works the best to catch us some fish? That is what we have to test in our experiment. Let's observe how bait fish swim underwater naturally compared to when they're hooked. Through these observations, it makes us think that the bait fish rigged up through the peduncle might work the best because it looks to swim more naturally. So maybe the fish hooked through the peduncle will work the best to catch us some fish today. So that is our hypothesis. The bait fish rigged up through the peduncle will work the best. The 3 different rigs of the bait fish are the independent variables because we are purposely changing them. And they are the ones that have the effect on what we catch today. So our catch results are the dependent variables. Okay, so it depends on how these fish are rigged. Every other factor, every other variable will remain the same. The location of where we're fishing, the time of the day, the weather conditions, the way we rig up our rod, that will all remain the same. The only thing we are changing is the way we are rigging the bait fish. That's our experiment. So while all experiments have experimental groups, not every experiment has a control group. Ours will not. So let's say we were testing whether or not your baitfish had to be alive in order to catch a fish. The control group would be a group of anglers fishing with dead baitfish, because you're testing whether it has to be alive in order to catch a fish. So another pair of anglers fishing with a live baitfish, that's the experimental group. But the control group would be the dead baitfish. In our experiment, we're testing which rig of a live baitfish will catch us the most fish, will work the best. So all of those are experimental groups. So where are we fishing today and conducting our experiment? And yes, I said we. I'll introduce my fellow anglers here in just a moment, but let's introduce the habitat. We are here at C.B. Smith Park here in Florida. It is a freshwater lake. It is very, very far west from the ocean, very much into the Everglades. So because it's a freshwater resource, we know that there are largemouth bass, a fish that is native to Florida and much of North America. Largemouth bass are a great target fish for the experiment because through our research, we do know that largemouth bass love to eat bait fish, okay? Also at C.B. Smith Park and a lot of freshwater locations around here in Florida, you also find the peacock bass. Now back in the 80s, the 1980s, FWC released some peacock bass in Florida, a few different species. Now, the reason for that though was to control the populations of other non-native fish that are actually becoming too invasive. They're invasive when they start taking over the food supply, the habitat of our native fish. Okay, so peacock bass were introduced about 30, 40 years ago to control other non-native populations like Mayan cichlids and spotted tilapia. And also these are a very, very fun game fish for recreational anglers to catch. A lot of people come to Florida specifically to fish the peacock bass. So this is another target species that we hope to catch today during our experiment.
So now that we know the basis of an experiment, let's go meet our fellow anglers who will be fishing today and conducting the experiment.
Joining us today, we have some of our IGFA volunteers. They are local high school students who have been with us for a very, very, very long time. They are getting their community service hours with the IGFA and they love fishing. So we cannot thank them enough for joining us today to do the experiment. So let's meet our fellow anglers. First we have Sam and Steven, and they are going to be rigging their baitfish up through
the dorsal right here.
Next we have Jake and Zach, and they will be rigging their baitfish up through
the tail.
Last but not least, we have Brandon and we have Nick, and they will be rigging their baitfish up through
the mouth. Hi guys, today I'm going to be using a spinning rod and reel with a 1/0 circle hook and a bobber that's 50 centimeters away from the hook. Today in our experiment, all of our rods we'll be using are set up the exact same way. This is because when you're conducting a scientific experiment, you need all of your variables to be the same so that you can compare and contrast your results with other experiments.
So we are using a 1/0 circle hook today, and yes, we are keeping the barb on there, but usually when we do catch and release, we crimp down the barbs. Okay, but for the sake of our experiment, we are going to leave those barbs on there, but every other time that we do catch and release, we do make sure that the barb is crimped down. But for our experiment today, a 1/0 circle hook, leaving the barbs on there. We're waiting for that first fish. Now, Jake, you just saw Jake cast his bait fish out there, and when he casted it, he lobbed it out there. That's one thing for bait fish. You don't want to whip it out there like a lure or something like that. You kind of want to just lob it out there so that you don't lose your bait fish.
Okay, so we are watching the bobbers. Okay, so what we're going to do is we are going to keep our eye on that bobber in the water, and when it goes completely under the water, that means we have a fish on. Okay, so number one, yep, check it off, good. What species is it?
Peacock.
Peacock bass, so write that down. Okay, so tip of the mouth.
Oh, I have a fish. Oh, wow.
Okay,
Oh my God, that was bigger than
it's 28.5. Okay,
Okay.
28.5, write it in the white. Okay, and now we can release.
So we went to cast, and technical difficulty happened, and the line got stuck in the bail, and it got caught. And when I went to cast, and I had a fish on, the line broke.
What fish was on? But because of our technical difficulties, we have to mark that fish as hooked a fish. But we did not land it because it hooked a peacock bass. But
Line broke.
that's probably Miss Lisa's fault. She didn't look at the reel to make sure everything was good, and it caused us to lose a fish today. It happens in science.
He's dead.
Okay, so we have one of our first bait fish right here. He's just about dead. That happens after you get a few strikes, or if the bait fish stays out of the water for too long. So we can mark this one off as died. Maybe we can get a more lively one up there and see if we can't catch some fish.
As our volunteer anglers fish, they will collect data as to what happens to each of their 12 bait fish. Did it die? Did it come off the hook? Did it hook a fish and we couldn't land it? Did it catch a fish? And if so, what species was it and how big was that fish? All of this data will help us analyze our results to come up with conclusions as to what rigged worked best. But in order to have accurate conclusions, this experiment and all scientific experiments need to have repeated trials to get a better idea as to whether the hypothesis was true or not.
Get it low, get it low, get it low.
Ooh, looks like another peacock bass. Head first. Get in front of his head. In front of his head.
Oh, that's not.
Woo! Tip of the mouth to the tip of the tail. Try to keep it as straight as possible. You said 36 centimeters, right?
36.
Yes, 36 centimeters. Perfect. So sometimes you need the pliers to get barbed hooks out. Okay, we got that. Now we are going to release it. There we go. He swims away. Okay. Looks like we have the front coming. We have a cold front coming. Excellent.
Nice, dude.
Oops, sorry.
You're good.
Oh, that's a nice one.
Yeah, there you go.
All right, look at that.
There we go.
Okay, so we are going to use an IGFA Official Measuring Device to measure this fish. You put the mouth against the board. We already wetted it so it takes off less slime. And it goes all the way, you measure in between the tail. So this is 40 centimeters. Largemouth bass. Okay, go ahead, Zach. We are going to release this fish. Get it back in the water. Nice fish. Back in the water. Swim another day. Fish on! Woohoo!
So we changed our spots. The fishing kind of slowed on the pier. So there are all of these little canals and little mini lakes inside of CB Smith Park. And we'll see what we can get. So experiment is still going on. Let's see if we can catch some more fish.
Fish on! Looks to be another peacock bass. Perfect. We'll put it on our measuring device. Mouth is against the board. This peacock bass is 34 centimeters, so we'll record that. But first, let's let him go. Good fish.
How our volunteers fish and try to catch some fish to get their data, I'm going to go around and do a little bit of a cleanup. Take a look at what we found. Some balloons. Yes, we're at a park. A lot of people come to parks to do birthday parties or things like that. And of course they bring balloons. However, please make sure we're all disposing of our trash properly. And balloons, do not let these go. What goes up eventually comes back down. And when it comes back down and deflates and starts to deteriorate, chances are it can come down in the water. And other fish or turtles or birds can mistake this for food, okay? They can't eat this though. This is a plastic material that's not part of their diet. So make sure we be good stewards to the environment when we get outside, when we go fishing, and enjoy the day. Keep our fishing spots cleaner than when we came here and found it.
Fish on! Ooh, look at that. Yes! Okay. Steven just hooked up on this largemouth bass and take a look.
It has someone else's line and hook in there.
Okay, so as we get our data for this largemouth bass, we will remove that hook as well. So go ahead, Sam. She is removing our hook, our circle hook. Excellent. And she's going to reach a little deeper to pop that hook out.
In there. Got it.
So environmental stewardship also means handling the fish properly and making sure that it gets back into the water as quickly, as safely, and as healthy as possible. So I am so happy that we were able to get this hook out of that largemouth bass so that it doesn't have to continue swimming around with another hook inside of its mouth. So if you ever come across that, just try to at least try your best to get the other hook or the fishing line out of its mouth so that it's not dragging that along with it. On again, fish on again.
Oh, that's a peacock. Nice.
Oh, nice.
Oh, it's not ready. It's not ready.
It's okay.
Go this way more. $38. Yep, 38, Lisa.
Okay. That was beautiful. Nice fish. Peacock bass. All right, what do we got here? Bring it up.
Yeah, Nick.
Nice, nice fish. Okay, we got the IGFA Official Measuring Device. We're gonna put the mouth against the board. Okay, straighten him out, straighten him out.
It's 40.
Grab him good, okay. Woohoo! Good job. Fish on.
So first shiner I caught Peacock Bass, 28 centimeters. Then for the most part we hooked onto fish, but they came off. Some died, but our last shiner we caught a big 40 centimeter Peacock Bass.
Hi, so my group and I, we hooked the shiner through the tail, and a few died, and we lost a few, and we caught 2 fish. One was a largemouth bass, which was 40 centimeters, and there was a peacock bass, which was 34 centimeters. It's a fun day.
Hey guys, so after our experiment has finished and we have collected all our data from fishing, here are the results. So our second bait fish caught us a peacock bass that was 36 centimeters. Our 9th bait fish caught us a largemouth bass that was also 36 centimeters. And our 10th bait fish caught us a peacock bass that was 38 centimeters. So all some big nice fish. Then we also had a couple bait fish in our experiment that had died. We had a couple that came off the hook, and we had 2 bait fish that we hooked up, but we didn't land the fish. So we weren't able to bring it in and count that on our experiment as a caught fish.
Okay everyone, I just want to thank you for joining us here at CB Smith Park and going through our experiment. We caught a lot of fish today. We had some fun. So thanks again for joining us as we're fishing Florida. And stay tuned for next month. We'll visit another park, another location, and catch new fish.